Heavenly Father, thank you for your love and kindness right now. Thank you for the blessing of life and your amazing grace that encompasses us right here in this room. And I ask that your blessing would extend into this class. You know what covering, what the importance of it is, and you can help discernment and understanding. And I pray you would, Father, do just that and more. In Jesus' name. Okay. So, So, I'm not going to take any more late assignments as of now. If you have stuff turned in, yowza. You keep me busy, buddy. Woo! So, this assignment, this article is due at what time tonight? Was it 5 or 7? 5? Okay. So you've got till 5 o'clock to do this article and have that turned in. I'm okay with that. But after that, I don't want to be grading papers all. I've got a pile to grade already. So, well, I've got most of the TQs for this class done. For the async class, I've got those to do, or I got some of them to do. So if you have some papers that you would like to turn in, then come and see me personally, and I'll talk to you about that. So I'm going to go over this TQ16. This is the last one that you've done, and if you turn them in, you can see what you got and what you didn't get. I like to mention when I'm watching this stuff, or when I'm grading papers, doing other things that I don't have to be focused on altogether. I like to listen to people talk about scientific stuff from a creationist standpoint, particularly. And John Lennox, who's not a recent young earth creationist, but he is a creationist. He's a great speaker, just a real thoughtful guy, has all kinds of degrees. But anyway, in spite of all his degrees, he's still a great thinker and communicator. And he said, a scientist, outside of perhaps a particular field, is as dumb as anybody else. So, they're just human beings. It's like, why would you listen to somebody that's a singer or an actor and get information on climate change, on economics, or anything else? Why would you go to them and listen to what they have to say? It doesn't make any sense. Why would they have an edge? But people flock to them. People flock to because they're a celebrity. So it's like they have an insight to anything. Well, if you listen to them long enough, you figure they don't have a whole lot of insight to stuff. They aren't as smart as anybody else, or they're as dumb as anybody else. So anyway, if you wouldn't listen, you got to be careful just because somebody wears a white coat that they have something to say about everything. They don't. And they might even be mistaken about what their field is. It's like Wilson. He's Darwin's champion in the biological science world. Just a great. They esteem him like top of the line. But his worldview is inconsistent with the truth. And if he was generated by random mutation and random mutation and unguided processes, Just change for whatever. Not for truth, for survival. So he got to where he is, not because we're designed to seek God and seek truth, but just from pond scum to where we are. There's no reason in it. There's no direction. And so here we are. Well, it takes away credibility from who he is. If we believe what he says, his credibility has to go down. Because just because he can talk about what he thinks is true, if he was created by random mutation and selection that's just arbitrary, it doesn't have anything to do with truth. So, and additionally, not everything the scientist says is true, even about their own field. So, even what I say, even what preachers say. I mean, I've heard some great things from preachers that said a lot of stuff I didn't believe, and they said one gem that just went, whoa. And it helped illuminate something. But that was because I was seeking God. I wanted to hear what God had to say. So, in fact, I've been convicted by a Rastafarian. And a Rastafarian is someone that heavily reads the Old Testament, smokes a little dope to get connected. And so you think, well, I mean, the Rastafarian is not going to speak to me. I'm a Christian. Well, God used him to. So God can use anybody, but it doesn't mean that anybody God uses is the way we ought to travel. Just like a guy in the church I was in when I was in Blacksburg, Virginia. The daughter of the song leader, had a boyfriend. And he went to a Carmen concert, and they had Holy Ghost dancers, and they had smoke, and they had all this stuff. And he got saved there. I mean, he got so radically converted in high school. He went on to college, went on to a degree in engineering, master's degree in engineering, I believe, came back and was teaching youth in Christiansburg, Virginia. I mean, he was radically changed. Now, does that mean Holy Ghost dancers and smoke for your Christian entertainment? Does that legitimize it? Well, no, not really. But it just says God can use anybody to do anything. He doesn't have to. He doesn't have to use people. But we want to be walking in His Spirit so He can use us. And so it's not just something that we're spouting off that doesn't have any spiritual work behind it. In fact, I might have told you before. But I listened to a fellow preach, holiness evangelist. This is back in the early 80s. And he was dressed early 80s car dealer. He had plaid pants, white shoes, a loud coat. I mean, he just looked like he came off a car dealership. I like cars. And I know car dealers. There was a guy graduated from here. In fact, I was part of my co-did his wedding. Great guy. Sells cars. But this guy, he just looked like well, it was typical, I guess, of high-end car dealerships. But anyway, so it doesn't matter. But he was preaching. And I agreed with everything he was saying. I mean, he was talking about standards and stuff, and I agreed with it. There was nothing wrong. But it just sounded harsh. But he wasn't harsh. He wasn't, but it had funny. And so the elderly man I was with, I asked him after the service, I said, Brother Norton, I agreed with what this guy said, but it just sounded harsh. And he said he didn't have the oil of the Holy Spirit. He wasn't in the Spirit, he was in the flesh. And you can say truth in the flesh, but it's not going to do the same thing that we'll do in the Spirit. Will it be total waste? Not necessarily. But you don't want to go there. So, what are thunderstorms, tornadoes, and hurricanes all related to? Low pressure systems. Some of you wrote stuff, but you needed to include either cyclones or low pressure systems. If you didn't have those two words in there, you got docked a point or two. Some of you described it, but what the focus was low pressure systems. You can talk about what they were, but you need to use cyclone or low pressure somewhere in there. And so what characterizes the air circulation associated with thunderstorms? Strong up and down movements of air, updrafts and downdrafts. That's what. There are things that are associated with this, but those are clearly. And a lot of these questions tie in. You should be able to find what's used. And you should. I mean, some of you did. I mean, you went right down the line, bang, 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 and got it. And so, and I didn't tell you. You got it from the book or somewhere, but you didn't. It should be clear enough from the questions asked that you could locate it in the book. And so, these are things, generally, these test questions, they're kind of rote. I mean, you just look in the book and put it down. But if you're studying for the test, getting these in mind are what you need to do. In fact, studying for the test, I even have numbered which ones from this thing you need to understand. So, if you look at your study guide for the test, and I sent out to everybody, you'll see which numbers and all these first handful are needful to understand. So, simplified, it's not, I know I was right, I put down the right answer. Well, if you differ with, if you want to talk to me after about your answer, I'm willing to adjust. And if I made a mistake, which I'm able to do, I'll correct it. If I made it against you, I'll upgrade it. If I made it in your favor, then you get it. You get the credit. You understand what I'm saying? So if you made a mistake, so your answer was wrong, and somebody has come to me, people have come to me and said, Mr. Nelson, I should have got this wrong. I got the wrong answer. Well, if I missed it, then it's on me, and I'm not going to correct it. You get the point. But if I mistook it, and you had a right answer, and I marked it wrong for some reason, then I'll make adjustments in it. So, if you have any questions on this stuff, then ask them. So, what kind of weather? Number 3, phenomena. What kind of weather? What kind of weather phenomena? Weather phenomena. That's important in there. Is generated and produced by thunderstorms, lightning, thunder, gusty winds, heavy rain, and hail. You could say tornadoes. You could say other things. But those 5 things, this one was worth 5 points. You got a point for each one of these things. Not too complex. What is one mechanism that significantly contributes to the formation of thunderstorms? You need to know this. It's the unequal heating of the earth. That significantly contributes to the formation of thunderstorms. Unequal heating of the earth. And that's based on, so what is this, the most significant item that addresses weather on this planet? What's the ultimate source? The sun, radiant energy. So that, and the sun does this, and this causes pressure gradients. It causes high and low temperatures to be existing aloft, which generates wind and whatever else. So, why do thunderstorms usually occur in the afternoon and evening? Because the ground, the earth has been heated all day long. And even though it's noon, the sun is still up. So the sun continually heats the land. And when the sun goes down, the land begins to cool. And it cools relatively quickly. But while it's up, it's still radiating on the land. And so that's why in the afternoon and early evening, the sun has been heating the land to the extent that it can before it starts to really cool, and so air instability and buoyancy are enhanced by high surface temperatures. That's what you get, and these are the highest in the afternoon, early evening. So what does a pressure gradient have to do with tornado development? Steep pressure gradient generates strong winds. Got a differential in pressure gradients. They generate, if it's a big one, the isobars, if the isobars the differential in isobars, we did that thing from the one before this, or the one before that. You made the general statement about isobars, depending on what the difference in wind speed is the difference in isobar spacing. So a steep pressure gradient generates strong winds, and when very steep, with a low in the center, or a cyclone in the center, air near the ground rushes in from all directions. So, but in order to have that, what's happening up above? You've got, if it's coming in, it's converging. So if it's coming in, it's being drawn in, it's converging, and if it's converging on the surface, it is diverging above. They're opposite. If it's converging, it's a low pressure area. It's a cyclone. A cyclone or low pressure is on the surface, means you've got converging winds. They're coming in. And that means that the air is being drawn up. And warm air is cooling anerotically as it rises, and it's condensing when it gets to the condensation level, and it's got air aloft that is diverging. It's spitting it out. It's drawing it up and spitting it out. So you need to know that. Concerning air masses, what two air masses, when they meet, can generate pretty intense storms? And why? Continental polar, air moving down from Canada, which is very cold and dry. You needed to say this and this. Beach maritime tropical air, warm, humid, and unstable, you need to say this and this. Coming up from Mexico. The greater the contrast between these two air masses, the more intense the storm. So the difference between the cold air and the warm air, as that increases, you've got a greater probability of intensity in storm. The farther the warm is from the cold in terms of temperature. So the next one, why do these meet over the central United States? It's likely. Why do you have Tornado Alley, which is right up through the Midwest? Well, there are no mountains. You can come right from Canada, you come sweeping down, and there's no natural barrier. And then you have coming up from Mexico, the same thing, no natural. You got the Rockies, but the Rockies are one, the Appalachian Mountains are over here, so it's pretty clear sailing. It's just flat up there. I mean, not everywhere, but mostly it is. Yeah. So, why? There's no significant natural barrier. You don't have mountains in there separating the center of the country from the Arctic or the Gulf of Mexico. So from all that, it's just flat all the way through. There's nothing to break it up. Hurricane damage could be divided in three categories: storm surge, wind damage, and inland flooding. So you have winds pushing the storm surge, and what comes after is inland flooding. Well, which category is responsible for the highest percentage of hurricane-related deaths? Storm surge. It comes way above what people expect. There's water just coming in more suddenly than not. But the greatest damage and significant lot of life can take place a day or more after hurricanes. Why? Because of inland flooding. How is a hurricane fueled? How is a hurricane is a heat engine fueled by latent heat liberated when huge quantities of water evaporate. So the water vapor is evaporating, releasing heat, and that is fueling the hurricane's movement. And that's why when the water gets above 80, 81 degrees in the Gulf, I mean, all that water is just being sucked up, it's just evaporating into the air. So you've got a body of air that's just having a mass of moisture. And so why does the intensity of a hurricane diminish rapidly when it moves onto land? Well, its source of moisture is cut off because it's no water anymore. Plus, it runs out for land, and so you don't see it so much, but there's friction. You've got friction then acting against the movement of the body of hurricane. You've got actually the ground acts as reduces the roughness of the land, slows the wind speed. So you've got friction acting against it, plus you have the elimination of its source of moisture, and that will eventually drive it out. Okay. And that is this. Okay, this is the lightning thing. So lightning strikes your surface about 100 times every single second. About 1 in 20 cloud to ground lightning bolts is positive lightning. A type of lightning that originates in the positively charged tops of storm clouds. Remember how storm clouds are typically, you've got a separation. You've got the negative charges basically down below, the positive up above. So there's kind of a separation. So you can get within cloud lightning between the two. But sometimes you'll get lightning coming off the positive part and hitting something that's negatively charged down on the ground. So it can happen. And that's why these things can shoot like 10 miles out. You could be 10 miles away from a lightning, the original lightning, and have it hit. So they reverse the charge flow from typical lightning bolts, extending from positive cloud to negative cloud rather than typical, and are far stronger and more destructive. Positive lightning can stretch across the sky and strike out of the blue more than 10 miles from the storm cloud where it was born. Typical lightning that accompanies thunderstorms is called cloud-to-cloud lightning, and is commonly referred to as sheet lightning. We don't see a hole, you can see it cross. This kind of lightning is caused by the negative to positive process with the elliptical building, and charge transfer occurs between the two clouds, not between the ground and cloud. Lightning in extreme heat can vaporize the water inside a tree. That's what, creating a steam that may blow the tree apart violently. That's what, I talked about that last time. How the tree on the campus just blew away. Well, this is what happens. The extreme heat vaporizes the water. So it's a steam altogether. So it expands and just blows the apart. So that's that. Now the last one I have to do is this one. I'm not going to do tornadoes. We don't have time for it.
till 9 a.m. with Gemini. It's free at Verizon, with plans starting at $30 a line. And this is Nicole asking, where the heck are you? And Gemini helping you respond in the style of Shakespeare. So give Google Pixel 9a on us and our new 3-year price lock guarantee with plans starting at $30 a line.
Violent winds, driving rain, killer waves. These are the hallmarks of a hurricane. Also called cyclones or typhoons, hurricanes are giant storms prowling the world's tropical seas. An average hurricane releases as much energy in a day as the explosion of 500,000 small atomic bombs. Hurricanes form in the summer and fall when the sun heats vast stretches of tropical ocean to over 82 degrees. Warm, moist air rises over these hotspots, creating thunderstorms. Upper-level winds and surface winds then come together, forming a circular pattern of clouds known as a tropical depression. When the winds exceed 39 miles per hour, a tropical storm has developed. When the winds reach 74 miles per hour, a hurricane is officially born. Inside the storm, bands of rain up to 300 miles long meet in the eye wall, the most violent section. Here, winds of up to 200 miles per hour spiral upward. Within the center of the hurricane, downdrafts of dry air create a strangely calm area called the eye. Fully formed, a hurricane may stretch over 500 miles in diameter. That's a storm nearly the size of Texas and reach a height of 9 miles. Most of these storms spin out over the open sea, but in an average year, 2 or 3 will strike the mainland of North America. When they do, the damage can be catastrophic. Most dangerous is the storm surge, a wall of water that sweeps across the coastline where a hurricane makes landfall. About 45,000 people were killed by hurricanes in the 20th century, including some 15,000 in the United States. Hurricanes are also costly in dollars. 1992's Hurricane Andrew was the most expensive natural disaster in U.S. history, causing more than $25 billion worth of damage. Scientists are searching for better ways to predict the path of a hurricane. Special planes called hurricane hunters fly directly into these monster storms and drop sensors to measure wind speed, temperature, and air pressure, providing vital clues to the hurricane's direction. New 3D models are also helping scientists understand this awesome force of nature and provide quicker and more accurate warnings to anyone unlucky enough to be caught in its path.
If you're trying to solve problems beyond, you're going to want to waste this time. There are a lot of people that are Medicare eligible that are enrolling in Advantage plans because of all the advertisement.
In this video, we're going to learn about tropical cyclones. The first thing you need to understand is that tropical cyclones originate over oceans in tropical areas and coastal regions. If you all know, this is the tropical region. It is the region of the Earth near to the equator and between the Tropic of Cancer in the northern hemisphere
Nothing over here.
and the Tropic of Capricorn in the southern hemisphere. Tropical cyclones are known by different names depending on the region. In the Indian Ocean, they are known by simply cyclones. If you go to the western Pacific side or near the South China Sea, it is called as typhoons. Likewise, near Western Australia, it is known by willy-willies. All these are different names referring to the same type of storm.
Same thing.
You must be knowing this, that tropical region receives the most solar radiation per area. And the reason behind that is due to the incoming solar radiation that are direct and vertical at the tropical region. And as you move towards the polar region, the angle of the sun rays are not vertical, they are slanting rays. Vertical rays of sunlight are more effective in producing light and heat than slanting rays. And that's why the tropical region is warm. Now that you have understood the main things about the tropical region, let's understand about wind movement. Wind movement is determined by low pressure and high pressure systems. It is the differences in atmospheric pressure that create creates pressure gradient and makes the wind move.
Diversion.
And wind always blow from the
Conversion.
high pressure to low pressure areas. Now the next question is, what causes low pressure and high pressure? Low pressure occurs when air is warm, either from being over a warm land or ocean surface. That means low pressure occurs at a place which is warm. And how does a place become warm? Because of the incoming heat from the sun. That is why tropical region is a perfect place where low pressure occurs. Similarly, high pressure occurs when air is cool, either from being over a cool land or ocean surface. That is why in the polar region, that is your north and south pole, it is a high pressure zone. And always remember, winds blow from the areas of high pressure to low pressure areas. While all of this happens, there's another important phenomenon which comes into the picture. It's called Coriolis force. Due to the rotation of the Earth rotates towards the east, and that's why the sun, moon, planets, and stars all rise in the east and go towards the west. Anyways, due to the rotation of the Earth, there is a force that is generated, and it acts perpendicular to the direction of motion and to the axis of rotation. In simple terms, when the Earth is spinning in its axis from west to east, and we also know that Earth is a sphere and it is much wider in the middle. As a result, the speed of the surface of the Earth at the equator is much faster than the speed at the poles. So if anything has to come straight from the poles towards the equator, it gets deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And this force that we are talking about is called Coriolis force. It causes fluids like water and air to curve as they travel across or above the Earth's surface. Due to Coriolis force, the air in the northern hemisphere gets deflected to the right side. Now you might think, no, that is going towards the left side, but then I said the air is going to curve to the right side in the northern hemisphere. To clear your confusion, you have to actually see it from the direction in which the wind is moving. So what I'm going to do is, I'm going to rotate this picture and now put yourself in the path of the wind. Now you will be able to see that the air in the northern hemisphere curves to the right while moving from high pressure to the low pressure area. Similarly, in the southern hemisphere, the air is deflected to the left side while moving from high pressure to low pressure area. In this case, we don't have to rotate the picture. Now that you have understood why the air moves to the left and right due to Coriolis force, just remember this point, that it is because of this reason there are certain pressure belts all over the Earth's surface. You must be familiar with this picture, which shows global wind circulation pattern. You can see that at different latitudes there are different pressure belts. Their existence is simply due to the movement of air to the left and right due to Coriolis force. I hope so far you have understood the general movement of air. Now let's understand how this air turns into a storm and what causes the spinning of a cyclone. When you look at the movement of a cyclone, at the center of every cyclone or hurricane, you will find an area of low pressure, which attracts the cool air. Since we know that air moves from high pressure area to low pressure area, that means the outer area of a cyclone consists of cool air coming from high pressure area, which surrounds the central low pressure area. This region is called the eye of the storm or center of the storm. The low pressure region is a warm region where the air is warm, which expands and then rises. The cool air from high pressure zone rushes in to fill the void left by the rising warm air. This air warms and becomes moist as well, allowing it to rise. Then more cool air rushes in to fill the void. The warm, moist air cools as it rises higher into the atmosphere because temperature drops with increasing altitude. That is also how clouds are formed. Now this process continues again and again. As a result, you will see an eye-like figure at the center of the storm. cyclones are intense, and in the beginning we have read that it occurs over the ocean surface and coastal region because there is a continuous supply of moisture from the ocean or sea. When it reaches the land, the moisture supply is cut off and the storm dissipates. When the cyclone crosses the coast, because after that the landmass starts, so the place where tropical cyclone crosses the coast is called the landfall of the cyclone, meaning the power of the cyclone naturally decreases because the supply of moisture is cut off.
This is the quickest way to clear out stuff pool.
The average diameter of a circulating tropical cyclone can vary between 150 and 250 kilometers. However, the diameter of the storm over the Bay of Bengal, Arabian Sea, and Indian Ocean is between 600 to 1200 kilometers. And these cyclones move slowly at a speed of about 300 to 500 kilometers per day. So far, we have seen the top view of a tropical cyclone, and this is what it looks vertically. This is the eye of the storm. Around the eye is the eye wall. If you look at the height of the cyclone, the circulation of the tropical cyclone extends up to the troposphere. That is around 15,000 to 18,000 meters. When warm, moist air rises up in the atmosphere, after a certain height, it starts cooling because the temperature drops with increasing altitude. As the air cools, it becomes denser and moves towards the ground. This is called subsiding warm air, and this is what intensifies the storm by increasing the diameter of the storm. And as the diameter increases, the spiral rain bands expands and pushes the rain clouds into the outer region. Tropical cyclones occur at the time of maximum solar radiation during the summer and autumn season, that is around July to October time in the northern hemisphere and December to March time in the southern hemisphere. With this, I hope you have now understood the complete anatomy of a tropical cyclone. If you still find it a little confusing, I recommend that you go back and watch the video again, especially the part where I said,
Okay. So, let me see. I don't know that we're going to do that. So, you're going to have a test in this room on Wednesday at 3 o'clock. And if you have a problem with that, like if you have three tests during the day, you can get one of them moved. I can't do anything. Well, Thursday and Friday are gone. I'm getting tooth pulled on Thursday morning, so I'm not going to be. I'm just going to have a hole in my head. Another one. But that's all I know. So you've got the. So you've all got this, should have. So this is an exhaustive item, but I should go over this again. But at the end of it, so I only went as far as test questions. You can see here, there's 1, 2, 3, 4, 5, 7, and 8. But you need to know about that stuff. You need to know some general details about lightning, what causes it, why thunder is, how hot it is, how it strikes. So, I'm not going to talk about hurricanes, although you are going to know about air masses. You're going to know about pressure gradients. You're going to need to know about those kind of things. So, that's a lot of stuff, but other than this last little section,